Okay, welcome everyone to assignment 1. Here's a workout review for you of assignment 1. So let's go right to the first page here. So the first question says, compute the amount of interest. So we're looking for I. On $2,500 borrowed at 10% per annum from September 30th to May 16th. Okay, well, so I is what we're looking for. It's a question mark. The principal is $2,500. The rate in terms of interest is 10% per annum, meaning year. And the time is September 30th through to December 31st, and from January 1 to May 16th. So what I'd ask you to do there is to go to your table or go to Google and figure out how many days in total we got to deal with here. So if you look it up, and I've looked it up ahead of time, it's 92 days in this year and 136 days in the January 1st to May 16th, for a total of 228 days. So that means that the loan will be outstanding for 228 divided by 365, because it's always a fractional of a year. So T will equal 228 over 365. Now, keeping in mind that the I equals PRT is the formula. So interest is a function of the principal times the rate times the time. So let's pull those numbers. The principal is $2,500 times the rate, which is 10%, 0.10. We turn it into a decimal, times the time, which is 228 divided by 365. If you do the math on that, and I've done it ahead of time here, that will come to $156.16. So what we're saying here is that the total amount of interest will be $156.16. And that's how you do that first one. Question 2. Question 2 asks us to say, question 2, as I find it here on my sheet, okay. Question 2. What principal will earn interest of $250 at 5.25% in 6 months? Well, what are some of the key things? Well, we're looking for the principal. So it's an unknown amount. We know that the rate is 5.25%, which in decimal form is 0.0525. The time, in this particular case, is 6 months. Remember, it's always a fraction of a year, so 6 months over 12 is the fractional, which would be considered our T. And the interest would be $250. Now, so we have 3 of the 4 elements. Keep in mind now, if we look at the I equal PRT triangle, we can figure out how to write our formula to figure each of those out. So in this particular instance, we are looking for the principal. So I'm going to pull P out of here. So that equals I over RT. If we run numbers into that, I, interest is $250, divided by the rate, which is 0.0525 times the time, 6 over 12. And if we do the math on that, that comes to $9,520. $523.81. In other words, we will need a principal of $9,523.81 in order to make $250 interest at the stated rate and time. Okay, that's number 2. Okay, next we'll take a look at number 3. Okay, so here somewhere. 4, 5. So next we'll take a look at question 3. Question 3 says find the number of years required for 2745 to earn $250 simple interest at 10% per annum. Okay, so we need to find the time in years. That's one of the things we need to do. So the principal, 2745. The interest is $250 in interest, and the rate is 10% or 0.10. Keeping in mind our I equals PRT formula, triangle here, we're trying to calculate time. So we take T out, T equals I over PR. We'll run the numbers for that. So I is 250. Principal is 2745 times 0.10, and that comes out to 0.9107, which is the proportion of a year. And we say, well, what exactly is that in days? Well, if we took 365 days year times 0.9107, that will work out to 332 days. And that's how you do that one. That's number 3. Okay, let's take a look at number 4. Number 4. Find the future value of an investment of $740 earning 10% per annum for 146 days. So we're looking for a future value here. And the present value, which is what it is now, is $740. And the rate is 10% or 0.10. And the time is stated in days, and it's 146 days out of 365. Keep in mind it's a proportion of a year. Okay? Now, seeing this is a future value problem, we have to use the future value formula. Future value equals to present value 1 plus RT. We learned that to be. So we just plug it in here. So present value is 740, 1 plus the rate, which is 0.10, times the time, which is 146 over 365. And that then, when we work the math on that, that's $769.60. So all this means is that the future value is how much this is the amount the investment will grow. Okay, in 146 days at 10%. That's number 4. Okay. Okay, now we're going to switch and we'll take a look at number 5. Number 5, compute the present value. Again, we're looking for present value of investment 8 months before its maturity date that earns an 8% per annum rate of interest and a maturity value of $2,000. Again, we really need to draw a timeline in here in order to get a sense of that. The present value and the future value is here. It's going to have a maturity value of $2,000, which is the future value. And it's 8 months is the time, and it's 8% per annum. Okay, so the question is then, what is the present value? That's what we're trying to find based on this information. So we are trying to calculate the present value. If we keep in mind now what the present value formula is, PV equals FV over 1 plus RT. So let's see what we got. Well, we know the future value is 2,000. We need to find the rate of interest is 8% per annum, or 0.08 equals T. And the time is 8 months, or 8 over 12, because it's a fractional of a year. So let's just plug those numbers in. So the present value is the future value, 2,000, divided by 1 plus R 0.08 times 8 over 12. And so the present value then is calculated to be $1,898.73. What does that say? It means that this is how much it is worth 8 months before. Okay, so it's a smaller amount. It's $1,898.73. Present value in 8 months, it'll grow to $2,000. That's number 5. Now we take a look at number 6. Next, we'll take a look at number 6. Number 6 says, what should the amount of each payment of $22,500 loan, what should be the amount of each payment if a 20... So let's take a look at question 6. What should the amount of each payment if a $22,500 loan at 6.5% is repaid by 3 equal payments due 2 months, 4 months, and 7 months following the date of the loan? So, okay, best thing we need to do here is to draw a timeline as per usual. We got now, and the loan is for $22,500, so we get $22,500 now, and we're going to make a payment on it in 2 months and 4 months and 7 months. Okay, so these are the payment point. Payment 1, payment 2, and payment 3. Okay, so what should the amount of each payment? So the payments are going to be equal. So we're going to call the payment X. Okay, so in order to do that, we recognize what we should know is that the present value of each of these payments, this one here, this one here, and this one here, has to add $22,500 in order to pay it off. So what we'll do is we're going to take that first payment and we're going to bring it back and find the present value of it. And we're going to take the present value of the second payment and we're going to figure out, we're going to take the second payment, find out the present value of it, and we're going to take the present value of the third payment and we're going to figure out the value of it. Now, those are all the same. The payment amounts be the same, but we need to find the present value. Now, the present value of this one plus this one, we'll call this one A, and the present value of B and the present value of C has to equal $22,500. Okay, that's the first thing we need to rationalize this. So in order to really do this, then we need to consider the present value formula for a payment. So what is the present value formula? We know the present value is the future value 1 plus RT. Okay, so that's the formula we're going to use in each of these cases. And we know that we can pull that information for each one. So let's say, for example, this one here, the first payment, well, it's 6.5%. Okay, so the rate in each of these cases, the rate is 6.5%, which is 0.065. The time, in the first case, in A, the time is 2/12 of a year, and in B, it is 4/12 of a year, and in C, it's 7/12 of a year. Okay, so that would be the key elements that we need to put in. And we know that this one, and this one, the present values of them added together will come to 2250. So let's formulate them. So we got to say that 22,500 equals, the future value is x over 1 plus the rate, which is 0.065 times 2/12. That's that first one. Now the second one, we add that to it, so that would be A. We'll call that A. And then the B part, we're going to take this one here. So it's x over 1 plus 0.065 times 4/12. And then we're going to do the C one. X over 1 plus 65 times 7/12. So that's effectively how that formula is rationalized. So this one, and this one come up to 2250. So now let's just narrow that by working each of these out. Okay, so 22,500 equals, and I've got that done. X is 1.01083 plus x over 1.02166, that's repeating, plus x over 1.037917. Okay, now what we're going to do is we're going to take this now, we're going to get x on the same, so this is the same as 1x, 1x, and 1x. So we're going to take 1x and divide it by 1.01. And this one here, we're going to take 1x divided by 1.02. We're going to take 1x divided by 103. So what we get is 2250 equals 0.98929x plus 0.97879x plus 0.963468x. We can add all these x, all these are common, so we can add them together. So 25,000 will equal 2.9315509x. Okay, so this is what we get there. We can solve for x by taking the 25,000 divided by, so and x will be equal to then 12. So each payment is going to be, so x will equal 767512. So that will be that first payment. X will be 767512, and x will be 767512. And that's how you resolve that. Okay, let's take a look at number 7. Determine the future value amount of $18,000 invested at 8% per annum, compounded quarterly for 5 years and 8 months. Okay, so we got some issues here. We're looking for the future value is the thing we're looking for, so that's it. We know that the present value, look, it's $18,000. And we know that the rate is 8% per annum. And it's compounded quarterly, meaning that we got to take 8 and divide it by 4 to get the per compound, or the rate. Compound equals 2%, okay, per period. Now, and the time is 5 years and 8 months. Now, we could figure this out. 5 years is 60 months plus 8, so 68 months. And we know there are 3 months per quarter. We need to convert it to a quarter because compounding is quarterly. So what does that work to? So 68 divided by 3 will give us 22.67 quarters. Okay, so we got to think how many quarters there are in order, because it's a quarter to compound it, we need that time needs to be in quarters. So in order to do this thing, in order to take that, we need to find the future value. So we use the future value formula. Future value is the present value 1 plus I to the n in the case of compound interest. The present value is 18,000. 1 plus 0.02, which is the per period interest rate, to n. N is the total number of compounds, which is 22.67. So if we do the math on that, we run that through our calculator, we will get 28,197.44. So in other words, the future value of $18,000 at 8% compounded quarterly for 5 years, 8 months is $28,197.44. I'll roll to that amount. That's question 7. Question 8. A demand loan of $100,000 is repaid by payments of $40,000 in 1 year, $50,000 in 4 years, and a final payment in 6 years. Okay, let's just draw this out. So we're going out now and we're getting a $100,000 loan. We know that that loan is going to be paid off year 1. We're going to pay $40,000 on it. Year 4, we're going to pay $50,000 on it. And I'll call these payments. And year 6, we're going to pay a payment on it. We don't know what that is. Whatever it is, it has to pay the loan off. Okay, so that's the basic thing. So now we've got different amounts in terms of interest rates. Okay, 9% per annum, compounded quarterly, and that occurs for the first year. And then it goes 5% per annum, compounded semi-annually. That goes for year 1 through year 4. And then we got 8.5% compounded annually for those 2 years. So we've got 1 year of this format, 2 years of this format, and 3 years of this format. Okay. Now, what we're going to do is work our way this way. Okay, we're going to work our way this way in terms of paying the loan off. Let's imagine now. Let's imagine that you're looking at your bank book or your bank statement. I'll call it a bank statement. That $100,000, you go and borrow that money, and the money is interest is being applied to that by the lending institution for that first year. Okay, let's just worry about that first year first. So we're only worried about to right here. Okay, so you say to yourself that $100,000 is sitting there. It's being charged 9% compounded quarterly, and at the end of the year, I should be able to figure out how much I owe on that loan. It's accumulated that interest. Once I figure out how much I owe on that loan, I'm going to pay $40,000 on it, so I'll take that amount off how much I owe. That will give me a balance, a new balance. That new balance then will be the basis for this second period, where we got 5% compounded semi-annually. That's going to take us through to year 4. And you're going to say, okay, well, you know, that interest is going to accumulate. I'm going to owe whatever the amount of money is that you calculate at end of year 4. And then you're going to pay $50,000. So you're going to subtract $50,000 off that amount. And then with that subtotal that you get there, having paid that money off, you're going to owe a continued amount on it. That's taking this 8.5% compounding. So that's going to grow with the amount you owe is going to grow with that interest. And at the end of year 6, you'll know what that balance is, and that's how much you owe on the loan. So that's the basic concept, what we got to do. So the first thing we need to do is find in order to do that, then we're going to take that 100,000 and bring it ahead of year. So we're looking for the future value. So this is step 1. We're going to take this future value of $100,000 at 9% compounded quarterly. Okay, so that's effectively what we're doing. So let's do the future value calculation and see what that is. So in step 1, we've seen, okay, we got to find the future value of that $100,000 brought ahead with compound interest. So let's take the future value formula for compound interest. F equals PV 1 plus I to the n. Okay, so we got the present value is $100,000. The interest rate is 1 plus, well, we know it's 9% compounded quarterly. So we've got to take 9%, divide that by 4, and that will give us 2.25% per quarter. So that's 0.0225. And it's quarterly, so 1 year of quarterly is 4 compounds. Okay, so that's to the 4. And that will come to 109,308.33. So essentially what we're saying is that $100,000 will grow to 109, or the amount owing will grow to 109,308.33 at the end of the year. Then you're going to make a payment. You're making that payment of $40,000, so that's going to come right off that. So we just take 109,308.33 minus the $40,000 will give us a balance of 69,308.33. Okay, so that's the balance at this point right here. Now, this point right here starts, so in other words, $69,000. We're looking for a future value of 69,308.33, which is the balance, in 2 years' time. Remember now, year 2, year 3, year 4. Oh, 3 years' time. 3 years' time. 2, 3, and 4. So 3 years of 5% compounded semi-annual. Okay? So again, we're going to use the same formula. If V equals PV 1 plus I to the n. In order to figure out the I, we know I is 5% compounded semi-annually. 5% divided by 2 is 2.5%. And that's that. And 2.5%. And how many compounds are there? Well, it is 3 years times 2 compounds per year, total of 6. So, based on that then, if V equals PV, which is the present value, which we've calculated to be 69,308.33, 1 plus 0.025 to the power of 6, and that comes to, the future value then comes to $80,376.42. So that means that at the end of year 4, we've got $80,376.42. We're going to make a $50,000 payment. So we're going to subtract $50,000 off that balance, and that will give us $30,376.42. So in other words, that's how much is owed on that loan after that payment's made. So you go into this last period. So we're looking for the future value of 30376.42, which is the present value effectively. And it's 8.5% annual. Okay, so that one's pretty straightforward. If it's annual, we got year 5 and 6, so we got 2 years of compounding at 1 per year, which is n equals 2. One compound per year for 2 years. And the interest rate is 8.5 divided by 1, which is 8.5 or 0.085. We'll run that through the future value formula as the present value, 30376.42. 1 plus 0.085 to the power of 2. So the future value then would calculate to be $35,759.88. So in other words, we owe that amount there, $35,759.85 at the end of year 6. That is how you complete that. And if you have any questions, you let me know. There's the first assignment.